Thank you very much for having me. I'm delighted to be here at my first BPS meeting. Michael made the case that there is a reproducibility crisis in psychology, lots of failures to replicate, identification of practices that we may have that increase the likelihood of false positives in the research that we publish, publication bias, where we leave out negative results and only publish the positive results, leading to exaggeration of the apparent health and vitality of the literature as we see it. And there is a lot of interest in what is thought of as, is there actually a reproducibility crisis? And Nature went as far as to say, let's ask people and see if they agree that there is a crisis. And so they surveyed 1,500 researchers, and 90% of them agreed that there is a significant crisis, or I don't know what a slight crisis is, but a slight crisis. So 90% of their surveyed researchers. Now, who are these surveyed researchers? Well, there are 700 biologists and 100 chemists and earth environmental scientists, medicine physicists. Psychologists are in other. This is our crisis, and they're taking our crisis from us and calling it their own crisis. And in fact, when they asked the chemists and biologists and others things like, have you had a problem reproducing your research results or others' research results? Most agreed, yes, this has been a challenge in our field. So while much of the public attention and interest in reproducibility and its challenges have been focused on our discipline, there is broad recognition that these are challenges across the scientific community for lots of reasons that we recognize easily in terms of the competitive nature and the challenging reasons of the ways in which we conduct our research that might lead to findings that are more beautiful than what we can expect or defend. So the conclusions that I want to draw are very similar to things that Michael highlighted in the introduction and Daryl has said in other talks, which is this is not a crisis in psychology. This is a reformation. We are changing over the last few years the way in which we do our research for the better. We are improving our scientific method on an ongoing, self-critical way of identifying things that we can do to make our research more robust and more reproducible and more applicable to social challenges. So it's a great time to be in psychology, not a bad time. And the second point is that other disciplines are recognizing that we are showing the way to do things better. That our field is taking a lead on establishing how it is we can do more robust science, because what we're effectively doing is applying our own psychology to our own practices. The work that has been happening in our field to change how it is that research gets done is psychological work. The challenges are not technical. The challenges are social, cultural, psychological. What are the barriers for reasoning for scientists needing to be the ones that do science? And how is it that the practices that we have can be shaped and nudged, the incentives that constrain our behaviors, so that the values that we have for science are the things that get embodied in the daily practice of what we do in science. And that's really, I think, the lesson that we can take from our own discipline to apply to how it is we do our science, and then give to the rest of the scientific community that's trying to wrestle with the same problems but doesn't have the same knowledge base of how they can tackle it in terms of the social and psychological aspects of how that operates. So what I want to do is talk first about what are those values of science. What is it that we're trying to do? How is it that we're trying to behave? What makes science a unique way of trying to figure out what things are, what is true about the world? And then why aren't we or are we living up to those values? So Robert Merton in the 1950s, early 60s, identified what he considered the norms of science. What makes science science, different from other ways of knowing things. Right? The first norm he identified, communality, the open sharing of information. Right? You don't trust a claim that I make because I say you need to trust it. I've made it. You get to look at the evidence. What's the basis of that claim? How is it? What's the methodology you used? What's the data that you collected? How did you draw inference from that data? As opposed to the counter norm. Nope, you just got to trust me. I said so. I'm a scientist. Right? Second norm, universalism. Research gets evaluated based on its own merit, right? You look at the evidence itself to decide whether the evidence is credible, rather than particularism. Well, that person's famous, so they must know what they're talking about, so I'm going to trust it. Disinterestedness. Researchers are motivated by knowledge and discovery versus the counter norm of self-interestedness, right? I'm just trying to get ahead of the people around me, trying to get as advantage any way that I can. Right? Organized skepticism. A researcher considers all new evidence, even against their prior work, versus organized dogmatism. What I do is I publish my dissertation, and then I spend the rest of my career defending it against all of the attackers around it in order to preserve the knowledge that I have contributed to the discipline. Right? And while Merton didn't talk about it, many philosophers or sociologists of science talk about a norm of quality as opposed to the norm of quantity. Now, these may be very recognizable as the norms or qualities or values that science suggests are how it is that science works. Anderson and her colleagues wanted to know, do people actually endorse them? Do scientists say, yes, those are the values of science? And what I'm showing here is the cumulative plot of the 3,300 or so NIH awardees that they surveyed, asking them, do you endorse the norms or do you endorse the counter norms in comparison to one another? And early career here are people who were in postdoctoral positions, all NIH awardees, and mid-career were people who were in their first R01 award, a major, usually 5-year grant from NIH, so average age around 40 years old. And what's showing in gray are the people who, on average, endorse the norms over the counter norms. So about 90% of people said, yes, the items on the left I endorse more than the items on the right. Whereas in black are those that endorse the counter norms over the norms. Nope, I'm here for myself. I'm here to defend my findings. I'm trying to just get ahead. Right? And the hatched lines are those that said these equally are important in science. So then Anderson and her colleagues said, that's fine, that's fine. Don't tell me what you endorse. Tell me what you do. How do you behave in your research? And it looks like this. So still 60% of people saying that they behave according to the norms of science over the counter norms, but many more are acknowledging that those counter norms have, if not equivalent or close to equivalent weight on their behavior. And still very few are saying that they actually behave according to the counter norms over the norms. So then they said, all right, that's fine. Don't tell me what you do. Tell me what the other people in your field, what do they do in their research? And it looks like this. Right? This is the important gap. Almost everyone agrees with the norms of research, of science, how science should operate. Mostly they say they try to live up to it, but they don't perceive the culture around them as reinforcing those norms. The culture, as they see it, is looking out for themselves, is dogmatic, is keeping things secret, is holding things to themselves, is advancing self-interest over what's in the interest of science. And as we know, when we perceive a culture around us to not embody the values that we have, that we think we should operate with, we confront a very difficult decision as an actor in that environment. I can behave according to the norms of science because I believe in them, and potentially disadvantage my career advancement because everyone else around me is not. At least that's how I see it. Or I could embrace the things that everybody else is doing because that's what you have to do to survive, and give up on the values. Right? But the irony, of course, is that we all endorse the values. Not everybody, but almost everybody effectively endorses the values of science. And so the problem is not in people's values. The problem is in what we perceive as what the culture reinforces. And so that presents an opening for change. If we have the values already, what we need to do is figure out what is the culture doing? What are the incentives structured as so that we can shift them just enough so that we can live by the values that we have and see the culture as reinforcing those values rather than being antagonistic to doing science the right way as we perceive it should be done. And so there are many discussions about what are the things that end up happening that produce that perception of a gap between what the culture wants and reinforces versus what we're trying to do. And around the research life cycle, there are many different types of behaviors that may reduce the credibility of the research in ways that are career advancing, but not enhancing the validity of the science. Right? Low statistical power, publication bias, leaving things out, p-hacking along the way. All of these are things that may end up producing a literature that looks more credible than it actually is. And so for us, the core challenge that needs to be solved, which is a social behavioral challenge, is that the incentives for my success are focused on me getting it published, not on me getting it right. That what I need to do in order to be most successful in my career is publish as frequently as I can in the most prestigious outlets that I can. And of course, I want it to be right, but that's not actually what the direct concern is in terms of incentives. The direct concern is getting it published. That's the reward that then leads to me getting more publications and more grants and more rewards of jobs and security and everything else. So once we have focused the incentives on the actual output, the publication itself, rather than the content, then we create an opening for all of those other kinds of behaviors to start to influence me in how it is I engage with my research. Right? I do 10 different studies, and 3 of them show evidence for my phenomenon, the other 7 don't. I start to reason to myself of why those 3 are the most correct ones, the ones where I did the methodology right. And those 7, those I screwed up. Something went wrong, and that's why I'm going to ignore them and put them aside and write a paper with 3 nice studies showing a nice, tidy story and clean narrative and not show the other 7. Right? There are lots of things that will happen with my motivated reasoning because I have a conflict of interest. My success is contingent on the results that I produce. And so because of that, I am more likely to do the behaviors without even intending to that lead to less credible results around that life cycle, rather than just focusing on doing the best possible science I can and reporting it as transparently as possible. So for us, this is the focus of what it is we can try to solve in terms of addressing how it is we can improve research practices. And ultimately, we think that it comes down to 2 very, very simple changes that are things that we know very well from our days in learning just how to navigate scholastic inquiry from kindergarten. And that is show your work and share. If we can be transparent in how it is we do our work and share the products of our work, not just the papers at the end, but the content of that research, what it is we generate in how it is we do our research, then the self-corrective processes of science will be able to operate as they're supposed to operate. Right? That's the wonderfulness of what science does as a distributed enterprise, is that I put a claim out there, I show you how it is I arrive at that claim, and the community debates the validity of that claim, looks at it in different ways, challenges it, adds skepticism. But the only way for that self-corrective process to work is for you to be able to see how I actually arrived at that claim. If you only see the paper at the end, then you don't have any insight into the content that I generated or the process that I generated in getting to that outcome. Right? I could have run 10 studies and reported 2. And if you don't know that, then you don't know how to evaluate and self-correct on the claims that ultimately came out. I could have run 100 analyses and only reported 10. If you don't know that, you can't critique effectively that research results. If you don't have a complete view of what the methodology is, you can't conduct a replication effectively to be able to test and extend or challenge the results that I've generated. So if we just can make that material accessible, then the self-corrective processes that are how science operates as a social system can operate more efficiently, and we will get to more credible results more rapidly. So what we have been spending our time thinking about at the Center for Open Science and with many, many others who have been engaged in this enterprise as a collective effort is how do we nudge those incentives and the norms of the culture so that we can live by the values that we collectively already have. And we think about it in terms of this pyramid where there are a number of factors that lead to behavior change across a cultural discipline on a wide scale. Right? First, we need technology that just makes it possible to do the new behaviors. So if there are behaviors that aren't yet done, we need some way for people to engage in those behaviors. Ideally, that technology will make it easy to do those behaviors. Rather than adding a whole bunch of extra burden of new things that I now have to do in order to get my research done, can we integrate those behaviors into the daily workflow, make it easy for people to transition into those behaviors that will be more effective? Right? Communities play a significant role. Societies define what the norms are. How is it that we operate as a discipline? What are the ways in which, unwritten or written, what's the right way, the good way, the effective way to be doing our research? Incentives then add additional interest. Now it's not just the thing that people do because it's a good thing to do, it's also in my interest to do those behaviors. And finally, where there are still gaps, we inject policies. These are the things that we have to do because this is what is required of us to do effective and efficient science. So what I'd like to do is talk about those in terms of the ecosystem that drives that individual researcher's behavior. Because for each of us, we have a unique set of influences on what it is that drives our individual behaviors. And because science is decentralized, there's no one source that can say, now this is how we're going to do science. If we're thinking about culture change, we have to think about it in the context of all of these different influences on my behavior, right? The institution that I'm in, the journals that I publish in, the societies that I engage with, the funders that support my research. All of these have expectations of me and are the ways in which I understand what it is I am supposed to do, what I can do, what I'm allowed to do, what I should do, what I want to do. So if we can't change all of these in some sort of tandem, right, it's a collective action problem at its core, then we won't be able to shift the culture effectively. And so there are a number of different initiatives at each of these different phases that try to think about how is it that we can collectively shift our incentives to promote more open and reproducible research? So I'll do this in two pieces. The first is I'm going to talk about the policies, incentives, and communities, giving some examples of ways in which we can try to shift behavioral practices. And then I'll do a brief bit on the technology that can support that change. So the first is top guidelines. This is a framework that was established in 2014-2015 with a community of researchers, of publishers, society representatives, and otherwise, to say what are the behaviors related to transparency that we are trying to promote, that we want to see as across different scientific disciplines relevant for increasing openness and reproducibility of research. And the group gathered examples of existing policies and guidelines from a variety of different sources and broke it into 8 components that are listed here, and then defined 3 levels of stringency. For example, if a journal wanted to say, we want to promote data sharing, make data more open, we can select that guideline, say data transparency guideline, and we can decide which of 3 levels we want to invoke in terms of our policies for authors that publish in our journal. It could be that they have to disclose whether the data is available, so we're not requiring it, we're just requiring you to say whether the data are available or not. We could require data sharing, and if people can't share their data because of intellectual property reasons or privacy reasons, then they just need to say that up front for the editor to be able to decide, is this a reasonable example for an exception to data sharing? Or the most extreme is we're going to verify. Not only do you need to share your data, but we're going to get your data and then reanalyze for the findings to make sure that the findings in the paper are reproducible from the data that you provide. So this framework is adoptable then by journals, by funders, by institutions as a shared set of standards that apply across research disciplines for what it is that people need to do, right? And that common language, especially language that can apply across the different communities and across different scientific disciplines, makes it a lot easier to have a shared understanding of what it is that needs to change and how it is that that needs to change. These now have there are something like 8,000 journals that have signed on to the top guidelines, and most all of the major publishers have signed on to the guidelines. So there's lots of progress there. I'll summarize a bit more later. A second example is a very trivial example of thinking about how incentives might change practices. And this is badges that were introduced first in psychological science, January 1st, 2014. Badges that are indicators of particular behaviors that are linked to the desired behaviors, the values that we project, right? Open data, sharing materials openly, and pre-registration of the design, right? I make commitments up front to what it is I'm going to do in this study, how I'm going to analyze the data in order to maximize confirmatory inference. So these badges, if researchers publish in Psych Science, they're invited. You may, if you like, get a badge for open data on your article if you make the data available in an independent repository, right? Meet the criteria for earning the badge. So badges themselves are silly, but the badges are indicators, icons of behaviors that are valued in the community, right? We value transparency. And there is, right now, before badges, there is no explicit indicators of whether someone is doing the extra work involved in making their data accessible and available to others. So there's no direct incentive for that behavior, and there's no visible indicators when others are doing that behavior. And so the question is just providing an indicator, this is happening, is that sufficient to then engage people in doing the behavior? And so we did a study of psychological science compared to 4 comparison journals for the rates of data sharing in that journal, pre and post badges. So this is the, by half year, 2012 through 2013, of the proportion of articles published in Psych Science in black and the comparison journals in gray that had open data in an independent repository. So psychological science, 3% of the articles on average prior to adopting badges had open data in independent repositories. We introduced badges on January 1st, 2014, and the data go like this. So by the first half of 2015, 39% of the articles in psychological science had data available in an independent repository, right? 3% to 39%, right? For a stupid little badge, right? But of course, it's not for the badge, right? It's a signal of the behavior that is a behavior that is already valued in the community. And so the change is a very simple one, but it is one to surface something that has value. The journal is communicating that it values this behavior, so it's offering the badges. And people that do it make evident that not only can it be done, that people are doing that behavior. And so I, as another observer, seeing that others are doing this behavior that I know is a good behavior means, oh, maybe I should do that behavior too. This is a norm. This is becoming a norm in our field. And so just that kind of signaling, making it explicit and obvious, is sufficient to have people who already have the values adopt those values in terms of their practices. Okay. A second example requires a bit of introduction about the role of pre-registration or pre-commitments. And we can refer back to our philosophy of science courses where researchers like Kuhn and others talked about 2 different modes of how research gets done. Right? In one mode of research, the context of justification, we are acquiring data in order to confront a hypothesis that we already have. Right? We have some belief about the world, and the reason to do the experiment is to confront that belief about the world, to see if our hypothesis, our existing belief, can predict something about the future, data that hasn't yet been observed. And so in that mode, we are doing hypothesis testing, right? The reason to get the data is to confront that hypothesis. And so the choices that we make, how it is we're going to test that hypothesis, what it is that we're going to do with the data, is independent of the data itself, right? We make those decisions, and then we acquire the data and confront whether those decisions actually predicted the future. Right, so this is often referred to as confirmatory testing, right? We have something and we're trying to see whether we can confirm or disconfirm the hypothesis that is pre-existing. The other mode of research is when we're in the context of discovery. We're not getting data to confront an existing idea. We're getting data in order to generate ideas about what could be true. So once I get into the data, then I start to look and say, oh, wow, this is interesting. I see that men are doing it this way, but women are doing it that way. Oh, this gives me insight for what it is that might be happening in the dynamics of this behavior. And so I am using the data to explore and generate hypotheses. And all of the decisions that I make are contingent on the data itself. The data influences my decisions of how I interact with the data. And so it helps me to get insight, ideas about what's possible, what might be true. Now, this is an important distinction because there are very critical things that between these 2 modes of research that have implications for how it is we generate inferences, particularly statistical inferences about what we're finding. And the key one is that p-values in null hypothesis significance testing are interpretable in confirmatory analysis, but they're not interpretable in exploratory analysis. We use null hypothesis significance testing as hypothesis testing. We have a pre-existing idea, and we use this method of statistical inference to give ourselves some degree of confidence of, if there's nothing to detect here, how unusual is this particular result? But the validity of that mode of statistical analysis depends on knowing the universe of tests that could be conducted on that data. And that universe is only definable if we know it before we observe the data itself. Because as soon as we observe the data, then the data influences the choices that we are going to make in how it is we analyze the data. So p-values lose their diagnosticity, sometimes completely lose their diagnosticity. So we don't know how to interpret it as a measure of unusualness, of how unlikely it is, because it depends on how many tests could have been conducted. So this distinction is very important, because if we present exploratory results as if they're confirmatory results, then we may increase the publishability of our findings, right? It looks like we found more things, but at the loss of the credibility, because we no longer can detect whether that apparent unusualness is a function of the various choices that we make along the way to get to what now looks like a significant result. Right? Andrew Gelman calls this the garden of forking paths, that as soon as we see some outcomes, those outcomes change the decisions that we make for the next set of analyses that we do, which changes the decisions that we make for the next set of analyses that we do. So the only way to have high confidence in those statistical inferences is to know that the tests were defined in advance of actually observing the data. And that is the key role of pre-registration, is to distinguish between these two modes of analysis. With pre-registration, I define before I've observed the data, how is it that I'm going to treat that data in order to test the hypotheses, to ensure that I'm making data-independent decisions about what it is I'm going to do to investigate whether my hypothesis or question is confirmed. Whereas everything else that I do, once I observe the data, is fodder for the next hypotheses that I'm going to pursue. So in every experiment that I've ever done, I have some reason that I'm doing it, often very mild reason, right? It may be a new area of research where I don't really have an idea of what's happening, but I have at least a reason to do the study. And in every study that I do, I look at the data in a million different ways to see what else I might discover that is totally different than my initial ideas, right? Both of these modes of analysis are vitally important for how it is we do our science, because we don't have hypotheses that are strong predictors of the world yet. Most of our advancement and discovery in science happens in exploration. But when we move what is from exploration and treat it as if it's confirmation, we assign p-values to it, we talk about it in terms of these are hypotheses that we can make inferences about with confidence, then we inflate the likelihood of observing false positives in our ultimate results. And so how is it that we can give ourselves some incentive to think about doing pre-registration when we have hypotheses to test in our research? And so one of the ways that we have been trying to increase engagement with pre-registration is something called the Pre-Reg Challenge. And really, this is an education and awareness campaign. We got a grant to award $1,000, $1,000 awards to researchers that publish the results of a pre-registered study. That was to get people to say, oh, well, that sounds interesting. Let's go see what this is all about, and go to the website. And what the website does is it provides some awareness and education about why one should pre-register, what conditions are pre-registration useful, and what are some just general context about the concept, and then provides a guided workflow to do what is a relatively intensive pre-registration process. There's alternatives that you can do that are a lot easier, but this is a relatively intensive approach to pre-registration so that people get some experience with it. And for our goals is, one, to actually start to test whether pre-registration is useful. Now that we have people doing it, we can do studies on people's behavior in pre-registration to see if it meets the promise that it has. And two, to see if it introduces a habit. That once one goes through the experience of pre-registration, then one says, oh, well, this is actually what I thought I was doing all along, but I see that it's now different. once I'm actually in this process of making commitments, explicit commitments, up front before I see the data. And then maybe that introduces some new behaviors and standard practice in how laboratories operate. So I'll show at the end some uptake on that. But I want to give one more example of trying to look at incentives for how it is people can change behaviors, particularly integrating into the daily work that they do now, the incentives as they're already structured in the system. And this is via registered reports. So this is the cartoon version of how research gets done, right? We design a study, we collect and analyze the data, we write the report, and then we publish it. But of course, it doesn't quite happen like that. There's this big barrier called peer review after we've written the report before the publication occurs. Now, in the context of doing the research in our standard practice, peer review is my enemy because my research is done. Now I need my reward, and I have to get through peer review in order to get my reward. And all of the incentives now are to make that report as beautiful as possible in order to get it through peer review so that it's accepted for publication. So all of those different behaviors that I could employ, deliberately or non-deliberately, to make my research more beautiful are all stacked up with me to try to get it through the peer review process. Right? And at this stage, if a reviewer identifies a problem with my research, then my only response is, you're a jerk, because I can't do anything about it. The research is done. So what Registered Reports does is one simple thing, is moves peer review to post-design phase. So now what I submit to the journal is my research question, justification for why that question is an important thing to investigate, and my methodology that I'm going to use to investigate that question. This is what the study will be. This is how we're going to do it. This is how we're going to analyze the data. The reviewers review that, decide, is it an important enough question, and is this methodology effective enough to test the question? And with that information, they make a decision about in-principle acceptance. Are we willing to publish this, regardless of outcome, if they follow through with the research effectively? And if they make that pre-commitment, then the later review that happens after the report is finished is not about the results. Are the results exciting or interesting or important or the way that they thought they would come out? The second stage of review is about whether the research was carried out effectively. Do you have evidence that you actually remembered in a neuroimaging study to turn on the magnet before you did it, right? So you can't do the research incompetently and still get it published. You have to show that you did the research competently, but it's no longer results contingent to make the decision to publish or not. This simple change realigns all the incentives for me and for the reviewers, right? So my focus is no longer on getting beautiful results. It's on asking important questions and designing beautiful studies to test those questions. When reviewers identify problems, I don't say, you jerk. I say, wow, thanks. I can change my methodology to address that and make it a more robust and effective study. So the reviewers become closer to collaborators than in the other way of doing the system. And that exchange also increases the likelihood that I'll actually get it through peer review. So I don't have to send the same paper to 10 journals, adding immense burden on all of the reviewers and all of the editors. Rather, if the question has any merit, some interaction between the reviewers, the editor, and the authors can iteratively refine that study to be a more effective study and get through the peer review process. So Chris Chambers will talk a lot more about this in the session after this, or one of the sessions after this. So I encourage you to go there. The purposes for this presentation is just on how it is those incentives can change as a function of changing where it is the review process happens. In the same thing that in both cases, I still need the publication. We're not going to change the fact that we need publications, at least not quickly, for advancement in our career. So because that is of pervasive interest, we can instead think about how is it that we nudge the incentives inside of how that process happens as usual. And so this won't replace all of our publishing approach because there's lots of stuff that doesn't quite fit in this model, right? Stuff does come up unexpectedly. We need to encourage exploratory work. Our current system does that quite effectively. But what we also can benefit from is making very clear when it's exploratory and what is confirmatory. So in the registered reports model, what you commit to analyzing is reported as the outcomes of the confirmatory design. And then anything else you do with the data is reported separately in the results as exploratory analysis, things that we discovered along the way. Happy to talk more about that, and Chris will say a lot more about that in the next session. Okay, so those are some examples of how we can look at shifting the policies, incentives, and norms that drive our research. I want to give a quick discussion about the technology to support those changes, why it's at the base of the pyramid, and then talk some about adoption. What is the evidence that some of these things are working? Our main infrastructure that we use to try to support this, Michael mentioned in the beginning, the Open Science Framework. We're actually moving to rebrand it as OSF because there's two things that are erroneous about that. One is that it doesn't have to be science. It's open to all scholarship. About 15% of our users are in the humanities or non-sciences. And it doesn't have to be open. You can use the OSF privately just for managing your laboratory's work and your collaborations and just make publicly accessible what you want to when you want to. So it's sort of like how Kentucky Fried Chicken went to KFC so you forget it was fried. We're going from Open Science Framework to OSF so you forget that it has to be open. So, or maybe they wanted you to forget it was from Kentucky. I don't know. But anyway, OSF is for project management so that when a computer in my lab blows up or a graduate student blows up, the data doesn't blow up with it, right? We now have a source that is cloud-based that backs up, so nothing we do anymore is ever lost. We can always find the work that we did. It facilitates ease registration, so it's easy to register those studies when we want to do pre-registration of research designs. And it simplifies data sharing, making the parts of that work accessible when you want to make it accessible. But a key part of the OSF is actually that the infrastructure, the tools that do all of the work for storing the data, for managing security, for authentication of who is it that has access, all of that is at a base level, and many, many different kinds of interfaces can be built on top of it. When you go to osf.io, it's a very open-ended interface for doing any kind of project management. It's unstructured, so you don't enter it and you, what do I do now? Well, I can create projects. How do you structure them? Well, you structure them however you want. It's very unguided. We can also build lots of other interfaces on top of it for very structured, very easy behaviors when I want to do a particular thing. So if you want to share a paper, particularly you want to share it in advance of publication because you want other people to be able to see it, you want to get feedback for the review process, you can go to SciArchive and share that paper. And it's a very simple 5-step workflow to share a paper, get a DOI, make it citable, and make it accessible to others. That is an interface on top of the OSF. So invisibly, you're still doing all of the same things on OSF. It's connecting to all of the other stuff if you already have an account in the OSF. But it's a very simple guided workflow for a particular behavior to increase openness. And that is a brandable interface. So what we do is we create a general interface for sharing papers. And then we said anybody that wants to start one of those services themselves and run it in their community can start one, and they run it themselves. So SciArchive is run by the Society for the Improvement of Psychological Science, and there are 19 other communities that are using their own interface that is the exact same infrastructure to encourage the sharing of papers earlier and faster. So this is an efficiency gain in the sense of a same technology can support many different uses by many different groups just by separating the core technology of what manages it from the interfaces of how it gets communicated. And we're doing that with a variety of different kinds of interfaces. So lots of meetings want to make it easier to share the outputs of the meeting, right? If you give a presentation, if you give a poster, the only influence that you have in meetings now is the people who happen to walk up to your poster or happen to come to the meeting or come to the presentation. So we have a meeting service that makes it very easy for societies or other groups to share the contents of their meeting. So people just email the OSF their title and PDF or PowerPoint of their presentation or poster, and it gets added to the meeting page for that particular conference. And then other people who were at the conference but didn't attend, who aren't even at the conference, can access that content to maximize the impact of sharing that. So that's a very simple interface that we can now make freely available to lots and lots of different conferences to make more of their research content more accessible more quickly. We also can make those interfaces for different kinds of sharing. So you can share papers. We can also make an interface for data, so a data repository very easily. So we have a partnership with APA. We haven't released this yet, but one of the things that we're building is a data repository for all data that's shared through APA publications. So if you publish an APA journal, they'll invite you to share your data. If you do, it'll get populated in the OSF in an interface that is for APA and for their journals. So they operate that interface. We just provide the technical infrastructure behind it. And we can create as many of these as there are communities that want to run their own ways of setting repositories. So the key link of this branding strategy with the initial items that I talked about is norm setting, right? Science is decentralized such that the influencers on my behavior are really the groups that are closest to me. Those societies, those individuals, those departments that are people that I interact with. And so if we can empower communities to start to promote openness and reproducibility themselves, give them just technologies to make it efficient to promote these things, then they'll be much more impactful on their local communities than any sort of general service can be on the community writ large. Okay, so let me just make a few notes about evidence for adoption of some of these behaviors, and then I'll be happy to have whatever time we have left for discussion. And the summary result is that there's lots of evidence that behaviors are changing. So just to return briefly to this approach to thinking about changing a research culture has an interesting parallel or relationship with models of behavior change more generally. So the most prominent one from Rogers, 1963, Diffusion of Innovations, talks about how new behaviors, new technologies get adopted in the community, right? And it starts with innovators who are the most early adopters, who see the promise, have vision for how it is that this kind of new technology could change how behavior gets done, right? Early adopters are ones who are willing to just jump in and try new things to see if they work, right? Early majority are influenced by the fact that this does seem to be working and it might actually provide some benefit to me and be aligned with the things that I want to do. Right? Late majority are people who say, oh, okay, everyone's doing this, so maybe it is something that I also should be considering doing. And the laggards are the people who still aren't on Facebook. I don't want anything to do with this. Like, this is not relevant to me. I'm staying out of this. Right? People who are very happy to stay with their ways. Right? If we think about rotating this, it maps on with the pyramid that I showed before. Right? For innovators, all they have to do is make it possible. They already want to do the behaviors. They just need a mechanism for doing it. Right? Early adopters will accelerate once that's easy to do that behavior. Right? They're ready to do it, but they're not going to go through all of the struggles. Right? Making it normative happens as that early majority starts to adopt it, because now we see that we're crossing this very small fringe community doing this behavior to many more people doing it. Right? By adding those incentives, it's a lot easier to bring along the rest of the majority. And for the laggards, you have to say, you just got to do it. Sorry, you got to do it. You got to do it. Okay, so if we think about that as an adoption process, we can look at how it is these various kinds of behavior change mechanisms for across the culture are working in that context. So just to give some data as illustration of some of the things I just talked about, here is across the 20 different preprint services over the last almost year, May 8th from last year to May 1st, yesterday, I updated the figure, adoption of preprints. So we had 2,500 preprints stored a year ago. There's over almost 11,000 today. So we have good acceleration across the communities. In SciArchive itself, just the psychology one, there's almost 2,000 preprints already shared through that service. OSF users, this is from when we initially introduced the OSF in 2012. It was just to my lab for a while there, so it's super small. To the end of last year, 2017. And I think actually I checked yesterday, as of yesterday, it was 90,248 users. So we have an accelerating rate of usage of the OSF across research disciplines, although psychology is the best represented community in OSF users. I mentioned the pre-registration challenge of seeing if people would adopt pre-registration as a practice. We have done a variety of different things just to try to illustrate shifting norms in that by including, for example, a leaderboard of the different institutions that have been participating in the challenge. How many different researchers, how many pre-registrations that they have. I'll note, since we are at BPS, that University of Oxford, UCL, and Edinburgh are all in the top 10 of this list. But you can see some adoption, but better evidence for adoption of pre-registration as a practice. Steve Lindsay and I published in APS Observer just a month or two ago this chart showing that in 2012 we had 38 pre-registrations on OSF. 2017 it's up to 12,090. And much of that is in social behavioral sciences writ large, and the majority of that is from psychology. Likewise, registered report journals. So you can do pre-registration without any tie to the journal, but pre-registration is a subset in the registered reports process. There are 88 journals as of the end of 2017 that adopted registered reports. As of yesterday, I think because of Daryl, it's 105, right? 105 journals now have adopted registered reports as of May 1. And we did a small effort I mentioned with the top guidelines, the framework for shifting the standards for what journals or funders or institutions might incentivize or require of their authors, their grantees, or their employees. We did a review of just a sample of 33 social personality journals to see what has happened with adoption of TOP in those journals, in that specific community. So there are 33 journals that publish some social personality psychology. They're not necessarily exclusively that, but they're all ones that have representation of social personality psychology. 70% have more than 0 steps on top. So I mentioned there's 3 levels. So we could just say if you get to level 1 on any of the 8, you get a point. If you get to level 2, you get 2 points, right? So we just sum up the points. So 70% have taken at least 1 step on one of those dimensions. And 52%, more than half, have taken more than 5 steps across these dimensions, either doing like a very aggressive data sharing policy and mild on other things, or small steps on multiple policies. And just to give you a sense of across the different types of transparency, what adoption looks like across those journals, there's wide representation, particularly replication has gotten the most attention, but even pre-registration, which is the most effortful of these for promoting adoption, has good representation already across this sample of journals. To give you a specific illustration of that, I'm just putting the top, I think 12 journals of that review showing the breadth and depth of adoption. And particularly notable are that at the top are mostly brand new journals, journals that have started in the last couple of years, have established themselves as being particularly assertive on their policies about transparency and reproducibility, right? Comprehensive Results in Social Psychology is an exclusively registered reports journal. You can only publish registered reports there. AMPS, Advances in Methods and Practices in Psychological Science, is the new APS journal that's edited by Dan Simons. They have a very assertive policy. Collabra is a new journal as well, and others are more established ones. Science is part of the design of the top guidelines, and they this January released their adoption of the guidelines, and they have very assertive policies on requirements for data sharing materials and code and disclosure of things like pre-registration. Pre-registration is almost unknown in most of the basic sciences. When I present at groups like Earth Sciences, I talk about pre-registration. They're like, that sounds super interesting. What is it? Never even heard of it. So there's a lot still of education to do in other areas of basic science. But just to show the other side as well, it isn't done. There are a lot of journals that have taken no steps yet on this. But that's the nature of social change. So while we can see that we can be very pleased that half of our community already has shifted practices within a very short time period. If we looked at this 3 years ago, every journal would have looked like this. So now that half of our journals in this particular subdiscipline are showing this change shows a very rapid shift towards greater openness and reproducibility. Want to just make a note, if you don't know about it, the Society for the Improvement of Psychological Science is a community that has gathered to try to do things like this and look at ways that we can change our practices within institutions, in training and education, in our teaching, in daily practice of any kind to improve openness and reproducibility. We had our first 2 meetings in Charlottesville at the Center for Open Science. This year it's going to be in Grand Rapids, Michigan. And next year it is going to be in the EU. It is a very diverse group, and I encourage you to look it up if you're interested in getting engaged in these processes. Okay, so let me conclude and then open up for some questions. The first point, again, this isn't a crisis. Reproducibility is challenging. There have been challenges and failures to replicate. There's been recognition of the behaviors like publication bias and even p-hacking since the 1960s and 70s. If you read papers by Bob Rosenthal and Jacob Cohen and Tony Greenwald from 1962 to 1975, you'll see identification of the same kinds of problems that we talk about today and the solutions to those problems from that time period. So the fact is that the challenges have been there presently. What's changed is that we as a community are stepping up and doing things about it. There are many, many people across the psychology community that are doing things to try to shift the norms and practices within the research community. And that's not failing to be noticed by people outside of psychology. So most of my presentations now, for example, are outside of psychology. And I go to meetings, like I was at the Council of Editors meeting for the American Chemical Society last month, and the introduction was, so as we all know, psychology has been doing so much work on increasing openness and reproducibility, so we invited Brian to talk about what's been happening there so that we can see how it is we can do some things better ourselves. So it is not lost on the community that we have identified and found ways to be self-critical in productive ways of how it is we are doing our research and identifying solutions that actually have some promise for effectiveness that can be exported elsewhere. So I hope that this generates some ideas and discussion, and if there's any of this that is of interest, here are some links that you could follow to get more information about any of these. I also encourage you to go to the next session on open science because they'll unpack lots of other things that are happening in even greater detail. So thanks very much for your time and attention. I appreciate it. Timing is okay?
About 4 minutes to take 2.